Hi, everybody. You can see this lecture in two formats. One, which is on the TV screen, one that's on your screen. And it's like this infinite picture of the whole thing. Actually, I'm not going to do that. We're just going to go ahead and run this PowerPoint that deals with mapping the Earth. So in chapter 2, we look at how we're going to map the Earth's surfaces. We talked about that with Eratosthenes a little bit and how he was able to do that. 300 years before Christ, or 300 BC, roughly 2 to 300. And now, of course, we've come a long ways with satellites and all kinds of different imagery and GPS. So now we're going to look at, first off, latitude and longitude. Well, we know the Earth is a sphere, but we have to be able to locate stuff on that sphere. So what we've done is, since really the big height of it was the 1700s when we figured out longitude, but we've known about latitude for a long time. But we use the global grid system. You've learned about this probably a couple different times in your educational career in elementary school and maybe middle school. The teachers probably talked about how latitude is like a ladder. So you're going up from the equator or down from the equator. The equator is the origin, and of course, the equator goes through places like South America, Africa, and things like that. We live up here in what we call the middle latitudes between 60 and 30. We're actually almost right smack dab in the middle. Our latitude here in Glendive is about 47 degrees north of the equator, so we'd right at 47 north. Longitude is what we use to measure east and west of a line we call the prime meridian. The prime meridian goes through Greenwich, England. Reason being is the English people were the ones that had the contest to figure out how we're going to calculate time when we're going across the ocean. So they had a ship clock contest, because ships, when they move, if you've ever seen an old clock, they got a pendulum in it. Well, when the pendulum's on the ship and the rocking of the water, all of a sudden the pendulum gets off and the period goes all goofy, and then your clock doesn't work. So the British had this contest to see who could develop a clock that would work with on a ship, so then they could calculate where they were at sea, so they could calculate time accurately. And a guy did, and he got kind of screwed out of the reward, got half of it at one point and another half about before he died. And that's a pretty good story about longitude. But anyway, longitude measures west of the prime meridian or east of the prime meridian. And if you know something about time zones, which you do in your book, we live in these Western time zones. As I go west across the Earth, I'm actually gaining time on the clock. So if I go from here to, say I go drive to Spokane, Washington, I cross the time zone line, the Pacific time zone, I actually run my clock back an hour, but that means I gain an hour. It's like I got a whole free hour. If I go towards the east longitudinally, which is the direction, the Earth actually spins counterclockwise, right, in the north, from the North Pole. So it's spinning this way. So if I end up going this way, it's like I'm going into the sun and I'm actually losing time, because I have to move my clock ahead to adjust for that. Well, if I move my clock ahead, it's like, oh, dang, I just lost a whole hour. It's kind of like what we do in the spring when we move ahead and all you guys are all tired because you come to school. It's like, oh, geez, I got screwed out of an hour of sleep, and you're all deadheads. Okay, so if you move your clock ahead, you lose an hour. If I travel to the east, that's what happens to me. The highest latitude you can have is 90 degrees. You can see that up here. So you're going from the equator, you can go up to 90 degrees. So the North and South Pole are both 90. We call those the highest latitudes based on the high latitudes have high numbers, low latitudes have low numbers, middle latitudes have middle numbers. So even if you're down here between 30 and 60 south, that's called a middle latitude. This part of the Earth from 0 to 30, those are actually the low latitudes. It doesn't matter if you're north or south of the equator. Low just means low in number. Kind of remember that, because I'll try to screw you up on a test with questions like that. Oh, the middle latitudes are 30 to 60. Doesn't matter if you're north or south of the equator. Middle means middle in number. Okay, so get that through your head. Longitude, like I said, the highest longitude you can have is 180. 180 over here is in the area of the world, we call that the international date line. That's actually also called the day change line. So if we're talking about time zones, if I fly from, let's say, Chicago over here, and I'm going to fly over here to Beijing, which I'm sure there's direct flights from Chicago to Beijing, you're going to fly over the international date line. Today is Thursday as I record this. If I hit 180, all of a sudden, bam, it's Friday. It changes one day ahead. If I go the opposite way from Beijing to Chicago, right now in Beijing, it's Friday. Beijing's capital China, by the way. So if I go from Beijing, China, and I go over that date line towards Chicago, now I go back a day. So it's like I gain a whole day. So theoretically, if you live on an island group over here in the middle of the Pacific, you could have like a couple different birthdays just by flying back and forth between those islands because you just change your days back and forth. So it's kind of an interesting phenomenon. But that's latitude and longitude in a nutshell. And of course, in this class, we get a little bit more picky with latitude and longitude because we can break it into pieces. And then we can study those pieces like really carefully and with more detail. And that's where we're moving ahead with the next thing here. We got a clock here. You have to think of latitude degrees as like a clock. This is the hour hand. 1 hour of clock time is almost like 1 degree of latitude, and we'll tell you why that is. Latitude and longitude on topographic maps, eventually we're going to get to that, but just in general, latitude and longitude. Topographic map, when we start looking at those in more detail, a topographic map shows only a fraction of a degree of latitude, either a quarter of a degree or a half of a degree, or in some cases, even an eighth of a degree. Well, how do we break apart a degree? Well, if we take 1 degree, you have to, like say, you have to think of it like a clock. 1 degree is like 1 whole hour, okay? And on a clock, you guys know that an hour has 60 minutes. So if I go a whole hour, that means that that second hand here has gone around 6, or that minute hand's gone around 60 ticks, okay? Because it's 12 times 5. There's 5 ticks in between, okay? So 1 degree has 60 minutes, just like an hour. We actually call them minutes too. So even though it's not like on a clock, it's just, well, it kind of is. So here's 1 hour on a clock, right? If I go to this 1 hour on a clock, that means I've gone 60 minutes to get there, which means it's gone around, this minute hand has gone around 1 whole time, okay? Maybe you're not very good at reading clocks. Well, I got digital. I don't need to look at the hands on the clock. So 1 minute is equal to 60 seconds too. So, okay, so if I have a minute, which is there's 60 minutes in an hour, in terms of latitude, there's 60 seconds in a minute, which if I take 60 times 60, that's 3,600, which means there's 3,600 seconds in 1 minute, which is also the same with latitude and longitude. So if I take and look at half a degree, it's just the same as saying half a minute. Well, how many minutes are going to be in half of a degree? Let's do the math. Or how many minutes are going to be in a quarter of a degree? Let's see if I can get my pointer to work here. Then we can actually do the math. Oh, there we go. I got a highlighter or a pen. Well, we'll use the pen. So half a degree is going to have 30 minutes. And the symbol we use for minutes is kind of like foot, like if I'm doing 30 feet. That's 30 minutes. A quarter, 1/4 of 60 is going to be 15 minutes. Looks like that. Now, if I want to go an eighth, then I just cut it down again, an eighth of a degree. So if I go an eighth, then I'm going to cut 15 in half. Well, 15 cut in half is going to equal 7.5 minutes. Now you're saying, well, where am I going with this? Eventually, you're going to look at topographic maps that are what we call a 30-minute quadrangle, a 15-minute quadrangle, or a 7.5 minute. So what I'm doing is I'm scaling up the Earth so I can look at things in a smaller area. And later on, we'll talk about map scale. So, but if I take that scale and I blow it up, now all of a sudden I'm able to see things better. It's like I'm zooming in on my microscope. This map right here, because I'm only looking at 7.5 degrees or minutes of latitude, it's going to show a lot more detail than this one that's looking at 30 minutes because it's like I've zoomed in. So in terms of the world, if I'm going to go out and actually say I'm going to go walk 69 degrees or 1 minute, okay, or I should say 1 degree. If I want to walk 1 degree of latitude, that's actually going to take me 69 miles. Or you could say roughly by rule of thumb, we used to say about 70 miles. So Montana, the southern border is at 45 degrees latitude. The northern border of Montana is at 49. So 49 minus 45 is 4. You take 4 times 70. That means from the bottom of Montana to the top of Montana, it's 4 times 70, which is about 280 miles, which is saying, well, if I go from Alzada down here in the corner, clear up to Plentywood up here, or Westby in this corner, it's about 280 miles. And that's roughly about what it is. Okay. Now, just to kind of move this thing, I wonder if I can hide this. Yeah, I can. So 1 degree of longitude varies. So latitude is always the same because latitude lines are parallel. All right. Longitude lines, they're not always exactly 69 miles apart because longitude lines intersect at the poles. So as the further north I go, the closer longitude degrees get together. So you can't say that longitude is always the same, but latitude is always the same, 69 miles from 1 degree to the next. Now, this brings up the idea of knots and nautical miles. Well, some of you maybe have heard this when you're flying in a plane. It'll tell you how many knots you're flying, or if you're in a ship or a boat, it says, well, the boat can sail at 18 knots, or we're going at 15 knots. Well, what the heck is a knot? Knot is kind of like the standard unit for measurement on Earth because it's based on the shape and the dimensions of the Earth. So it's a much more universal way to measure distance and speed and those kinds of things. Well, just to kind of go through this real quick. Do I still have my pen? Yes. It's based on degrees of latitude. Remember, you can't use longitude because longitude gets closer as you get to the poles. And it's also based on 1 minute of latitude. So if I'm going a nautical mile of latitude, it's basically 1 minute of the Earth's dimension, okay, which equals roughly about, where's my pen? Oh, here it is. It equals about 1.15 statute miles. So if we're looking at the Earth, and here we've got a picture of the Earth, right? We show that 1 degree is equal to 60 minutes, what we just talked about. And 60 minutes says 3,600 seconds. Well, 1 minute, right, which is, there's 60 minutes in a degree. So if I take 69 divided by 60 gives me this 1.15, right? And like I said, this is a standard measurement for if you're in a ship, airplane, whatever, they're going to tell you, or even wind speeds, they're going to measure them in knots. So if you're seeing a speed, well, the wind speed today is 15 knots. Well, guess what? That's faster than 15 miles per hour because you got to take it times 1.15. So roughly a nautical mile is about 6,660 or 6,068 feet versus statute mile, which is 5,280 feet. So if I'm covering that in the same amount of time, that means I'm going faster if I'm going 1 nautical mile. For those of you metric lovers out there, a nautical mile, or I should say a knot, is 1,852 meters, where if you remember, if you're a track and field person and you're running the mile in track and field, you run 4 laps. Well, 4 laps is basically like 1,600 meters. So that just is kind of a comparison. So if you ever hear the term knots and nautical miles, it's really a better way to measure speed and distance because it's based on the true shape of the Earth. And we've known about nautical miles in terms of shipping and things like that for hundreds of years. The sailors used to have a big winding on their ship, and when they were charting these are guys sailing with sails and stuff, with Chinese and the Europeans, they could chart their course using a big rope with knots in it, and they would throw out this weighted deal, and it would zip out the rope, and as the ropes went by, they had knots in the rope, and that's where all these terms came from. So, but anyway, that's it for today's lesson. There'll be, like I said, 10 questions or so down in the description. I would have this done by Friday night. So that way your parents can say, by God, you do have something to do in school. Better get it done. Otherwise, I'm taking away your car or your car insurance or your phone or something else that you would like to have that you shouldn't have because you're not doing your work. Okay? I'm signing out.